In the previous function, we were able to authenticate users and make sure that they had actually logged in with a valid token. But we still want to make sure now that users can't modify other users' information even if they've logged in. This is the process known as authorization. And it's going to follow pretty similar to what we did before. We are going to try once again to get the token. We'll also make sure that we catch any potential errors. And we are going to grab from the headers a header called authorization, and we will split by a space and grab whatever is at index 1. We're then going to call the verify method, just like we did before, which accepts as its first parameter some kind of string, some kind of JSON web token, and then the secret key, just to make sure that we can decode it correctly. The secret key is important for encoding and decoding. It has to be the same for both of those. And then we're going to run a function to see if everything went well, or if we get back an error. What we're going to say here is instead of just if decoded, we want to make sure that if there is a token and inside of the token, the ID in the payload is the same as whatever is coming in the URL, then we let it go. Then we'll allow the user to move on. So what does this mean? Inside of our URL, it's probably going to look something like what we saw before, /API, /users, /some ID, /messages. And what we want to think about here is what happens if user ID number 2 tries to make a message for user ID number 4. Well, they still might be logged in. User 2 might be logged in, but the ID in their payload is going to be 2, and rect.params is going to be 4. This is going to prevent users from tampering with other users' information. And this is the idea of authorization. It's essential when building more secure applications. So what happens if you don't have the right ID? Well, we can still return next, but this time we're going to pass something to it. A status, once again, of 401, unauthorized. But this time the message will simply just say unauthorized. And if that happens as well inside of here, if we try to decode the token and it fails, let's do that same exact thing. So where are we actually going to use this middleware? Well, we're going to go back to our index.js and we're going to import it. And inside of our index.js, we're simply going to grab login required and ensure correct user. And those will both come from requiring /middleware/auth. And where are we going to use this login required and ensure correct user? Well, before you get to messages routes, let's first make sure that you're logged in. Let's then make sure that there is actually the correct user. So what's the idea here? We're going to make sure that you're logged in before you start creating a message. We're going to make sure that you are the correct user, and then we'll let you start actually creating messages. So let's test this out in the terminal and see if it does what we want it to do. We saw previously that someone could just simply write a message for someone else. So what we're going to try to do is change this to does this work? And let's see if we can successfully post as someone else. And we see right away, please log in first. Well, how come we got that please log in first? That's coming from our login required middleware. We're not just going to let you start creating a message until you've logged in. So what I'm going to try to do now is make a new user. And I'm going to make a post to localhost 8081/API/auth/signup with a username of hacker, a password of hacker, and an email of hacker@hacker.com. And this should create a valid JSON web token. But what I'm going to try to do now is try to write a message as Ellie using the hacker's token. The hacker doesn't have my token, they only have theirs. But we're going to try to take this token and see if we can kind of forge a request as Ellie. So we'll go to localhost 8081/API/users/myuserid/messages. This is the post that should create a message. We'll pass in an authorization header, a bearer, and then the hacker's token. We'll then pass in the text of hacked. And let's see what happens. When I do this, it tells me unauthorized. Why is this happening? This part of the token is getting decoded. It's getting decoded by the server using the same secret key that it used to encrypt it. And inside of my middleware, it's simply telling me that the ID of the user with that token is not the same as the ID in the params. And that is the idea of authorization, stopping someone with a certain ID from accessing someone else's information with a different ID. So even if we made sure you were logged in and you used a totally valid token, we still need a little bit more authorization to make sure you're not allowed to write other messages for people. It's a really tricky concept, so I encourage you to practice this with HTTP or Postman, see what these tokens look like. You can also, if you'd like, go to jwt.io and take this token and decode it with the secret key that you've made to see how it's all working under the hood.